Once we understand the anatomy of an angle, then we can begin to measure those angles. In section 1.1.2, we'll consider the degree measure of an angle. Definition: if a circle is divided up into 360 equal arcs, each arc is said to have a measure of 1 degree. This is written as 1, and then we have a degree symbol right here. It is vitally important that any time you express an angle in degrees, that you include the degree symbol to distinguish it from a radian measure, as we'll learn later in the semester. The measure of an angle alpha, denoted m of alpha, we would read that the measure of angle alpha, indicates the amount of rotation from the initial side to the terminal side of an angle. So essentially, there's two ways to measure the size of an angle. We do that in degrees or in radians. And both of those measures are describing the amount of rotation from the initial side of the angle to the terminal side of the angle. You are probably familiar with the fact that there are 360 degrees in a circle, but have you ever thought about why? Why do you think 360 is used to divide up a circle? Well, we all live on a common great circle or great sphere called the Earth, and the sun moves approximately 1 degree each day. For that reason, a lot of calendars are based on a 360-day year. In fact, the Babylonians had a base 6-number system, and that's conducive also to the 360-day year. So 1 degree is 1/360th of an arc around the circle. Definition: the degree measure of an angle is positive if the rotation is in the counterclockwise direction, and negative if the rotation is clockwise. Now, that's going to be a little bit mind-boggling if you're unfamiliar with trigonometry. Did you catch that detail? The angle is positive if it's measured in the counterclockwise direction. So if we consider the initial side of the angle to be on the positive x-axis, and we rotate to the terminal side in the counterclockwise direction, that is a positive rotation. On the other hand, if we rotate from the initial side to the terminal side in the clockwise direction, that is a negative angle. That can be a little bit counterintuitive simply because we're dependent on clocks. Clocks rotate in the clockwise direction. Time ticks forward in time. It seems like the other way should be true. Rotating clockwise seems to be positive, counterclockwise seems to be negative. But in trigonometry, the initial side of an angle in standard position begins on the positive x-axis. A counterclockwise rotation, that is from positive x to positive y, is a positive angle, and a clockwise rotation from the positive x-axis to the direction of the negative x-axis is a negative angle. In addition to sine, we can classify angles based on their size. An angle with a measure between 0 degrees and 90 degrees is called an acute angle. An angle with a measure between, not including, but between 90 degrees and 180 degrees is called an obtuse angle. An angle of exactly 90 degrees is a right angle, and an angle of exactly 180 degrees is called a straight angle. You'll want to be familiar with all of these special vocabulary words. Let's use those descriptive vocabulary words to classify the following angles in example 2 based on their measures. The first angle there has a measure of 20 degrees. Notice it's in the positive direction because we are rotating in the counterclockwise direction. So this is an example of an acute angle because it has a measure between and not including 0 and 90 degrees. The second angle, because the measure is greater than 90 degrees but less than 180 degrees, this is what an obtuse angle looks like. The next example is exactly 180 degrees. We call that a straight angle from the positive x-axis to the negative x-axis. And the last example there is a perfect 90-degree angle, so this is what we call a right angle. So we can easily classify angles based on their size. Let's widen our perspective a bit and consider angles all the way around one rotation of a circle, or 360 degrees around the circle. An angle in standard position is said to lie in the quadrant where its terminal side lies. So if we look at the diagram below, the angles 30 degrees, 45 degrees, and 60 degrees would all be classified as quadrant 1 angles. Now, if the angle has its terminal side on an axis, we say that the angle is a quadrantal angle. It's on the division between quadrants. So, for example, 90 degrees would be a quadrantal angle, 180 degrees, as well as 270 degrees, and 0 degrees, or also known as 360 degrees. Do notice that the angles are increasing in the counterclockwise direction because we are considering positive angles. Now, the angles that you see listed on that circle there are very important and common angles. We'll be using these angles all semester, so you will definitely want to familiarize yourself with the location of these angles in the quadrants. The angles in quadrant 1, 30, 45, and 60. Notice here we have a rotation of 30 degrees, and then the difference here is 15 degrees, the difference here is 15 degrees, and then 30 degrees here. So these are not equally spaced angles. If we continue rotating around the circle using those measures, then 30 degrees beyond 90 degrees, we get 120 degrees. 15 degrees more, we have 135 degrees. Another 15 degrees, we have 150 degrees. Those are our quadrant 2 angles. And then we can continue rotating 30 degrees more until we get to our straight angle of 180 degrees. And this pattern continues around what we're eventually going to call the unit circle. Now, we can use those basic locations to help us to identify the location of the terminal side of some non-common angles. In example 3, we want to name the quadrant in which the following angles lie, or we'll just notice that they are quadrantal angles. So the first example there is 72 degrees. 72 degrees is bigger than 60 degrees, but less than 90. So it probably lands around here somewhere. Again, its initial side is on the positive x-axis. So we would say that this is a quadrant 1 angle. Notice example B is a negative angle. In that case, we're going to rotate in the negative direction. But sometimes, especially if you get a large angle, it's nice to imagine where that angle is in the positive direction first. So positive 112 degrees is past 90 degrees, but not quite to 120 degrees. So that would be the terminal side of positive 112 degrees. I'm going to go that same distance, but in the negative direction. So I'm going to go beyond that negative y-axis to approximately, and remember these are approximate, about right here. So negative 112 degrees looks like a quadrant 3 angle. The next example that we're considering is 270 degrees. Notice we're going to rotate past 90, past 180, and then we're going to land on the negative y-axis. So 270 degrees lands on an axis, therefore it is a quadrantal angle. Because it does not belong to either quadrant 3 or quadrant 4, it is on the boundary of those quadrants. Again, we call it a quadrantal angle. 153 degrees is just beyond this common location that we can see over here, 150 degrees, and it looks like its terminal side is there in quadrant 2. The last example is positive 300 degrees. That's one of our special angles our special angles on the unit circle. So we're going to go from the positive x-axis, rotate around to 300 degrees. We can see that lands in quadrant 4. Now, this is very simple and straightforward information, but again, it is vital information. You will want to familiarize yourself with the location of these specific angles on the circle. To help you practice that, I encourage you to play this degrees quiz game. You can bookmark this website and play this a couple of times a day this week as we learn these angles in Chapter 1. So here's how the game works. An angle is going to be given 330 degrees, and I'm going to locate that angle with my mouse and simply click the point that that angle intersects the circle at. 270 degrees is the next example. Then we have 150 degrees. We have 315, so on and so forth. This is just a great way to quiz yourself and make sure you know the locations of those important angles. Once again, this information is fundamental and simple, but very important. So please take some time to memorize the locations of each one of those angles on a basic circle.